Now what we're going to do is we're going to look at solving linear inequalities. For linear inequalities, we're going to solve them similar to linear equations. The only difference is we're going to be graphing them. So for letter A, we're going to distribute the -2 to each of the terms, and that gives me -2x plus 8 is less than 10. Then I'm going to subtract the 8, and that gives me -2x is less than 2. So when I divide it by -2, what I'm going to get is x is greater than -1. Now notice that I switched the inequality. The reason that I switched the inequality is if we have two numbers, 2 and 10, and I were to subtract 2, what I would get is 0 and 8. Now I know that 10 is greater than 2, and notice that when I subtract the 2, 8 is greater than 0. Now, if I had the 2 and the 10, which of course 10 is larger, and I were to divide it by -2, what I notice is I get -1 and -5. Now I notice that the -1 is greater. So whenever we multiply or divide by a negative, what happens is the values change. So in order to make the statement true, the inequality has to change also. Now when we're graphing it, we're going to put a -1 in the middle. I'm going to put an open circle because there's no line underneath. It's just greater than, so it's all the values greater than, and then I'm going to draw my arrow to the right because it's greater than. Now, if I'm looking at my next example, I have the 4 times the x, which is 4x. I have the 4 times the 7, which is -28. Then I am going to subtract the 2x in order to get the x's on one side. And that gives me 2x minus 28 is greater than 6. I'm going to add the 28, and I get 2x is greater than 34. Then what I'm going to do is divide it by 2, and so x is greater than 17. When I graph this, I'm going to put 17 in the middle. I'm going to put an open circle, and then since it's greater than, it's going to go to the right. Now, looking at the next one, I'm first going to distribute the negative to each of the terms. So I have 3x minus x plus 7. And then I distribute the -4. So that gives me -12 plus 4x. I'm going to add the like terms. 3x minus x is 2x. 9 minus 12 gives me -3. Next thing I'm going to do is I'm going to subtract the 4x. That gives me -2x plus 7 is less than or equal to -3. I'm going to subtract the 7, running out of room here, and that gives me a -2x is less than or equal to -10. And then when I divide by a -2, I get x is greater than or equal to 5. So once again, I put the 5 in the middle. This time it's a closed circle because it's equal to 5, so it includes 5, and greater than means it goes to the right. Now, the next three that I'm going to be looking at are going to be compound inequalities. So we have an absolute value, and if you remember from last time, when we write an absolute value, we write 1 where it's 2x minus 1 is less than 5 because we know that the absolute value of 5 is 5. And the other one is -5 because the absolute value of -5 is also 5. Now, with this right here, when we write the second inequality, what's going to happen is because we're changing the value of the 5, we're changing the inequality. So I'm going to add the 1, and I get 2x is less than 6. I'm going to divide it by 2, and I get x is less than 3. Then I'm going to add the 1, and I get 2x is greater than -4. I divide it by 2, and I get x is greater than -2. Now, I slipped in an and here. The reason that we know it's and is because this is a less than statement. If it was a greater than statement, it would be an or statement. All and statements are going to be in the middle. All or statements are going to be on the outside. So this is going to start at -2, end at 3. They're both open circles, and the line goes in the middle. Now for letter E, this is a compound. This is also an and the reason that we know it's an and is because the x is in the middle. I'm going to solve this, adding the 2 on both sides. And when I add the 2 on both sides, I get -3, and then 3x is less than or equal to 21. And then I divide both sides by 3. And then when I do that, my x is in the middle. I have -1. I have 7. That is my answer. And then when I graph it, I have -1 open circle. I have 7 closed circle. And since it's an and statement, my line is in the middle. For my last one, this is an or statement, obviously, because it says or. I'm going to solve both inequalities. The first one, I add the 2, and I get 5x is less than -25. Then I divide it by 5, and I get x is less than -5. For the next one, I subtract the 8, and that gives me -3x is less than or equal to 3. Then I'm going to divide by -3. And when I divide by -3, remember the inequality switches, so it becomes greater than or equal to -1. So I have the -5 first, I have the -1 second. This is open, this is closed, goes to the left, and this one goes to the right.